All right, it is Floral Shirt Friday, and I want to go ahead and talk about the Fukushima water again. I already talked about how you'd have to drink 3.5 gallons of the water that they're releasing in order to get the same radiation dose that only one Brazil nut will give you. But let's go ahead and talk about a little bit of a different perspective here. And a little bit of warning too, we're going to get into a little bit of math. So the concentrations of tritium in the Fukushima water are 1,500 becquerels per liter. But to most people, 1,500 becquerels means nothing. So tritiated water looks like this. Instead of having two hydrogens attached to an oxygen, it's a hydrogen, a tritium, and an oxygen. That tritium is chemically identical to the hydrogen. So in the Fukushima water, they're releasing both of these. But how many of these tritiated water molecules are there compared to the regular water molecules? So what I want to do is convert the number of becquerels per liter of water, which 1 kilogram is a liter of water, into tritium units, which is 1 tritium water molecule per 10 to the 18 regular water molecules. When you do the conversion, you can see my math down there. For every 1 tritium water molecule, there are over 78 billion regular water molecules. So usually when we're talking about certain contaminants being released into the environment, we're talking about parts per million or parts per billion. So how many parts per million or billion are they releasing from Fukushima? Well, it's so small, it can't even be measured in parts per million or parts per billion or even parts per trillion, but in parts per quadrillion. 12.7 parts per quadrillion of tritium water molecules. But that is such a small number, I think people have trouble even conceptualizing that. So let's go ahead and talk about how much pure tritium water would you need to add to an Olympic-sized swimming pool in order to get to the same concentration. So an Olympic-sized swimming pool is approximately 2.5 million liters of water. And 1 drop of water is approximately 0.05 milliliters. So first I want to find out how many drops of water are in an Olympic-sized swimming pool. So we have here the 2.5 million liters, and we convert that into milliliters by multiplying by 1,000 and dividing that by 0.05 milliliters per drop of water. And that gives us 50 billion drops of water in a Olympic-sized swimming pool. So if you take that number of drops and times it by the fraction of the number of drops that are tritium water, you'd find out that you'd have this many drops of tritium water, which again doesn't really help with perspective. So how many swimming pools in order to get this number to 1? Well, all you got to do is inverse the fraction by taking 1 divided by that number, and you'd get about 1575. So in order to match the concentration of tritium in the Fukushima water, you would need to take 1 drop of pure tritium water added to 1,575 Olympic-sized swimming pools. And that really just shows how sensitive our instrumentation is. And it's a double-edged sword, unfortunately. Just because something is detectable does not make it dangerous. The dose matters.